And most of you most of you know that a pointer is reference to another variable. That means whenever we talk about pointer variables are a variable which points to the address of the another variable. Now, therefore, when we talk about a pointer, it always contains an address. Now, the question comes, pointers contain addresses. It means pointers are always integers. Now try to understand the concept. Pointers are always integers. Therefore, the size of pointer will be always equal to the size of an integer value. Now, let us take a thing that if I am going to use, suppose I write a like this, I write integer. I write three lines, integer star A, float star B, and double star C. Now, you should be very clear that A points to an integer, B points to a float, C points to a double, but A, B, and C all contain integer values. Therefore, the size of occupied by A or B or C will all be equal. Therefore, don't confuse that float B will take more value, C will take even more value, A will take, even if I write like this, for example, if I write character star D, if I write like this, suppose if I write like this, if I write like this, character star D, it means that D points to a character, but the number of bytes used by A, B, C, or D are all equal. It means A, B, C, and D, A, B, C, and D takes equal memory. Takes equal memory. It takes the memory equal to the size of integer, which could be 2 or 4 bytes depending on the compiler to compiler. And therefore, it is used to, that is the most important concept, that pointers always stores the variable address of another variable, and you are going to use these pointers in order to uh, store the address of another variable. Now, the one of the very important line is written over here. It is written over here, used to change variables inside a function. That is also called a reference parameter. Now, tell me one question: how many values a function can return normally?
One. One,
It,
sir.
it can return only
One.
um, one value. Normally, it can only return one value. That's perfectly correct. But if I want to return more than one value from a function, what should be done? Suppose I have a main program and I have passed some parameters to a function, and that function manipulates many values, and all those values should be available to main. I cannot return more than one value. What you said is correct. Now the question is, how can I return more than one value?
Return
Sir,
using pointers we can.
using array pointers.
That means you have to use arrays or pointers. If I'm using an array, arrays are basically pointers only internally. That means this is a line which I wanted to come, used to change variables inside a function. Therefore, this is a variable written over here. It means that you can very well change the variables inside a function, not a variable. That is called a reference parameter. Therefore, whenever you are going to use the most uh, important point about a pointer is that it used to change variables inside a function, and for that we pass a reference parameter. Okay? Therefore, you are going to now you already we have done in the last class. It is used in dynamic memory allocations, especially for arrays, used in building complex data structures like linked lists, stack, queues, and trees. Therefore, in many of the program, what we'll do in the case of stacks, queues, and trees, or linked list will always be done using pointers. All programs of linked list will be done using pointers. Stack queues can be done in both ways. Trees graph mostly will be done by pointers or some in case of arrays only. But you have to keep in mind that whenever we are using an arrays, the the static allocation will always be there, and therefore you cannot overcome the static allocation what is associated with an array. Now, this is the thing which we'll cover in this class. The outline of presentation, the basics, variable declaration, initialization, null pointer, the ampersand operator, the indication operator, the pointer parameter, return values, casting points, void star, and so on. Then we'll cover the arrays, the 1D array and the simple pointer passing as parameters. Then a dynamic allocation, the calloc, free, malloc, realloc. And we'll cover the dynamic two-dimensional array allocations. Okay. Now these are the things we'll cover. Now just to make you aware that in the exam of this CN303, you will have one program which is coming for 6 marks from pointers. Therefore, that is also a part of the theory part. Apart from the lab, it will also have a theory part with that. Now, this is the pointer basic. Some of you might be knowing this, but just I will start from the very beginning. Variables are located at address in computer memory. That means it depends on the computer and the OS. I already told you the memory is allocated by the operating system. The compiler requests the OS to give the memory. Therefore, the whole memory is in the control of the operating system. And those of you who will study in the further classes, you know that one of the main important work of a OS is to perform memory management. That is the memory management. The second work is to perform processor management, or called process management. Process management is a concept where more than one process are occupying in the memory, and the OS will execute one by one. Therefore, there are at least 4 different tasks of memory OS, and memory management is one of the tasks. Now, name of the variable is a reference to that memory address. Yesterday only I told you that when I am talking about name of the variable, it is a reference to that memory address. A pointer variable contains representation of an address of another variable. Therefore, P is a pointer variable in the following. Now, if I am going to use a thing like this, if I am going to write like this, say integer v is equal to 101, it means that v is occupying some memory, and 101 is the value of this, is having a value. Then 4 bytes of integer value is occupied by 101. You know that when I store 101, it is in the form of binary. That means it converted in the form of zeros and ones, and it will have a binary value of 16 bits. Okay, sorry, 32 bits, 4 bytes. And v is the name of the variable. Therefore, it is having some name. Now, whenever you write this statement, what does the compiler will do? It will ask the OS to allocate 4 bytes of memory. Now, the 4 bytes of memory is given to this, and that 4 byte, the value is put over there as 101. And there are internally some tables maintained by the compiler. One of the table is called a symbol table, and the symbol table, that is also in short form we call it symtab. And the symbol table will store the address of all the symbols you are using in your program. That means once this line is executed, V will be put in the symbol table along with the starting address of that variable and the value for this. Therefore, whenever you are going to search for a variable, it searches in the symbol table. Okay. Similarly, when you are declaring a pointer star P ampersand V, P is a pointer variable. Since here V is an integer variable, therefore I declare P also to be an integer pointer because I am going to store the address of an integer. Therefore, this is there. Therefore, I am using this pointer variable V over here. Now, in this case, whenever this you find that I am declaring P over here, P will also have 4 bytes of memory because I already told you that all pointers are integers. Therefore, it will also have the same 4 bytes of memory. And the address stored at P is nothing but the address of V. Therefore, let us take an example. Let us say compiler gives you an address of 2510. Now, in this case, 2510 will be stored over here. Whatever address is assigned to V, that address will be stored in the value part of P. Therefore, the value part of P is the middle one. Therefore, this is the value part. This is the value. And it will store the address of P. Now, since P always stores the address, you cannot write a statement that P is equal to 2510 or P is equal to put directly assign. Therefore, if I write something like this, say P is equal to say 2600, if I write like this, it is totally wrong. You can't write like this because P is an address. It can only be assigned an address. If you are assigning like this, it looks that you are assigning a value. Therefore, P will always get in the form of an address of some other variable whose who in turn stores an integer. Who in turn it stores an integer. Now, therefore, this is the meaning that whenever a pointer is being declared, you have to make sure that what is the type it points to. Now, this is the basic type. You write the type of the variable along with the star name, where you can write integer star P, float star Q, character star R, and here P is a variable that can point to an integer variable, Q is a float pointer, R is a character pointer, and so on. Now, these are the basic syntax for declaring a pointer. Now, I say R is a character pointer, Q is a float pointer, P is a that means it means that Q is an integer which points to a float. I can also say that Q is an integer which points. That means internally Q is an integer which points to a float, but Q is a pointer. Okay. Now, other complex type is like this. I can write integer star AP5. That means here AP is an array of 5 pointers to integers. Now, if I am going to give you how it actually happens, it will be something like this. Like this: 0, 1, 2, 3, and 4. Now here it is AP. Therefore, AP is an array of 5 pointers to integers. Now here, what will be the content of this? The content of this will be an array which contains the address of contain the address of a pointer integers. That means AP is an array. It's an array of 5 pointers to integers. Now, whatever you are going to store at these places, they should be pointers. They should be pointers to integers. That means you cannot store a data into these values. You have to store a pointer which in turn points to an integer. That means it can contain over here maybe 2520, maybe 2610, 2850, 2900, maybe 3000. Now this 25, 20, 26, 10, 28, 50, 2900, 3000 are not values. These are basically pointers to integers. That means there will be some 2520 will be some location which might contain some integer, say 5. There might be some other location like this 2610 which may contain some value, say 25, and so on. And these are the one which are stored over here. Now these are addresses. That means this is an integer, star is the pointer, and 5 is an array. That means AP is an array of 5 pointers to integers. Now, if I have not written a star over here, it would have been a simple array. Now, in that case, if I am going to write like this, if I am going to, suppose if I am going to write like this, and if I'm going to write like this integer, if I write like this, now in this case, it contains all values. It will contain all values, maybe 3, 2, 6, 1, 8, and all those are values. But once you put a star over here, this will all be addresses. This all will be addresses. And it will not contain the value. Therefore, once I am going to dereference it, I will be getting the value from here. Now, if I am going to write the want to get the value for this, I have to come to this place. And from here I can address the values. I want to know what is the value stored over here. I have to come to this place, and from there I can get the values, and so on. Similarly, I could write integer star star also. It could be there. Therefore, these stars can be like, it can be written like this also. And when I am going to write like this, it means that you are going to declare a double pointer. That means A is an array of 5 pointers to an integer to an integer. That means A is a array of 5 pointers to integers, which again points to an integer. Therefore, since there are 2 stars, I will write that A is an array of 5 pointers to an integers who are again pointing to another integer. Therefore, it's a double reference. Now, whatever value stored in A will point to another pointer. That pointer will point to another pointer, and that will contain the value. Therefore, you can extend this star to 1, 2, 3, 4, 5, anything, but more than 2 star doesn't find any application in computer science. Most of the time, you will use either a single star or a double star. When you are trying to read a 2-dimensional array, we'll use a 2 star. If you are going to read a 3-dimensional array, obviously you will use a triple star. If you are going to read an n-dimensional array, you can put n star, but that will create confusion at the end. Therefore, more than 2 stars are hardly used in anywhere, but 2 are frequently used. If you are passing a 2-dimensional array from one function to another function, you require to pass as a double star. That means if I have a function main and I declare a 2D array in a main and try to pass this 2D array to another function which will return, which will accept that 2D array, I require to use a double star. Okay. Now it means that if you are having a 3-dimensional array and I want to pass a 3-dimensional array to a function, that function will accept that array using a triple star. That's perfectly valid. But in a normal scenario, you hardly use a 3-dimensional array. Now, the address operator can be used in front of any variable objects in C. The result of the operation is the location in memory of the variable. That means when I'm going to use like this, for example, I'm writing the ampersand variable reference. In this case, you are writing like this. I can write integer v, integer star p, integer ap, and I can write ampersand of v. It means that memory location of integer variable v. I can write integer of ampersand of a of 2, memory location of array element 2. I can write ampersand of p. It means that memory location of pointer variable p. Now here you have to understand that if I am going to write the memory map for this, it will be somewhere like something like this. You will have p, you will have some address, value I have not put because I have not equated somewhere. Therefore, in that case, if I am going to write address of p, it will print this value. If I am going to print this, it will print this value. If I write simple printf ampersand d address of p, it will point this value, which will be given by the compiler, which will in turn get it from the OS. Now, once I am going to declare this variable, now p will going to point will assign 4 bytes of memory. Let us take an example. The 4 bytes of memory which is assigned to this might be say 2501, 2, 3, and 4. Now there are 4 bytes of memory. Now if I am going to use a printer with this, it will print 2501. If I am going to print, say if I am put address, if I am going to print say star p, I am writing printf star p, it will print this. If I am printing ampersand p, it is printing this. Because once you are writing a star p, it means you are going to dereference the p, and therefore it will point to the value part. That means star indicates value at address. Value at address. Value at address say p. Okay. Now in this case you are going to dereference it. Okay. Now whatever address what is stored over here, you are going to go to that location and pick that value over here. Okay. Now it means that let us take an example. I would have assigned it to say 10. Okay. And I could have written like this. Correct? I wrote integer v is equal to 10, integer star p is equal to address of v. And then I am writing printf star p. Now what happens? The value assigned to v will be stored over here. Let us take an example. Let's think this is 2450. Now when I write this star p, what happens? It goes to location number 2450 and picks the value, which is 10. Now, how is the memory map of v? It will be something like this. It will be something like this. Now, when I am putting integer star p is equal to address of v, it is putting this value over here. It is going to put this value over here. And if I am writing a statement, printf percentage d or percentage u, with if I am writing a statement like this, say printf ampersand u star of printf percentage u star p. It prints 10. Output will be 10. Because it means value at address. Value at address what? P will be replaced by 2450. Therefore, this will be replaced by 2450. That is stored by 2450. That means you are going to use the here you are going to use this thing, and therefore whenever I am using this value, it will be something like this. That value at address 2450, it will go to this place and will pick 10 over here. That means value at address 22450 is P. Now, if I have written like this, if I am going to write like this, let's take if I am going to write like this. If I am going to write like this, if I am going to write printf ampersand u p, what is the output? Printf percentage u p, only p.
2450.
Correct. It will print the output over here will be 2450 because you are going to two four five zero. Now, if I am going to say like this, if I am going to write like this,
2501 or the address of P.
Address of
that
P.
means it will start with the address of P, which is nothing but somewhere, this is nothing but this one. But since it only prints the starting block, they will give you 2501. It will give you 2501, which is the starting block of the address. And therefore, this is how you make no mistake while trying to dereference a pointer variable. Make no mistake. Otherwise, what happens? It will be giving you. Now, if I write like this, what is the meaning?
Address of V.
What is the output now?
So 2450.
Address of V, sir. 2450.
Correct. It will be 2450. Now, in that case, you are going to find. Therefore, the meaning is that if you are using the star with an ampersand, it is nothing but equal to P only. That means it is as good as writing only P. That means once you are going to get the address and then dereferencing it will actually cancel both. That means actually this and this will cancel one another. And it is nothing but P. Okay. Therefore, this is the meaning that you can very well play with the pointers, provided you are very much aware that how the memory map is being generated for that and how the map is being used like this. Therefore, whenever you are trying to use, you can write very well. Instead of writing P, I could have written ampersand P with a star. That means you are first going to the address and then dereferencing it. Once you dereference, it comes to the value part. Whenever I put a star, it means you are dereferencing. Now make it very clear. Once I use a star somewhere, you have to check the value part only. Once I am going to put, that means you have to check the middle part. You have to check the middle one. You have to check the middle one. Whenever I write a star with any pointer variable, it means you have to check the middle part. Now, in some cases, middle part might contain the value. In some cases, it might contain an address. But whenever a star is there, you means you are going to dereference it. Okay. When I am putting an ampersand, you always check the address part. Whenever I am putting an ampersand, you always check the address part. Okay. Now, a pointer could also be initialized to a null value. A pointer constant to non-existing address that is used to indicate points to nothing. I can write over here, for example, I can write star p. I can write like this also, star p. It means I am pointing p to a null value. Now, why did I write null in capitals? Can I write in small letters?
Sir, it's a keyword. So,
Okay, it's a keyword. Any one of you differ with his statement that it is a keyword? Is null a keyword?
Sir,
It's not a
So it's a
keyword.
data type.
It's not a keyword. There's some small thing you missed it out. It's not a keyword.
सर मैक्रो है ये.
It is a predefined macro. It's a predefined macro. That means you are just using like this hash define. You might have used this statement somewhere. Now, when I write like this, it means that you are going to define n is equal to 50. And whenever you are writing n anywhere, it will take the value 50. This is your definition of, you have defined a macro. But here, null is already defined as a predefined macro. Therefore, you cannot write in small letters because in C, you know that small and capital differs. And then if you write a small null, it is not a predefined macro. Therefore, this is a predefined macro. Therefore, in this case, you can initialize P to null and it will contain a ASCII value of 0. Null is an ASCII value of 0. Therefore, it is used to initialize and assign pointer values to null or use the address of the operator to get address to the variable. Variable in the address operator must be of the right type for the pointer. That I already explained in last class, that even if there are two variables, both are pointers, you cannot equate among them since the type of the variable is different. Therefore, you have to use it must be of the right type. It must be a type. That means whenever you are using a variable in the address, therefore you require to typecast it. You want to typecast it. Now here is the example very clear. You are declaring v over here. I can put the address because this is integer star. Okay. Now, if I am declaring an array like this, I can point to like this ampersand of A2. A2 is a is a location, maybe the third location. If I am taking from 0, the third location, it means the address of third location. It means the address of third location. And address of third location is nothing but a simple integer star. Therefore, I can very well use it like this. It is like this. Now, suppose I am declaring like this A5, I might be having maybe I might, since an integer, I have put it, I have put say 3. I could have say 3, 2, 6, 5, say 4. That means it is going to go to 6, third location, the address of this will be taken care. Now, in that case, when I am going to assign A, it might give an address of 2000. That means this is stored at 2001. This is stored at 2005. This is stored at 2009, 13, and 17. Total, it is how much? How many? 20 bytes. Because the last one will be stored at 17, 18, 19, and 20. 4 bytes. That means this will be stored from 3 will be stored from 1, 2, 3, 4. 2 will be stored at 5, 6, 7, 8. Similarly, this will be stored at say 9, 10, 11, 12, and so on. 4 will be stored, this one, the 4 will be stored at 17, 18, 19, 20. There will be 20 bytes to 2001 to 2020. And therefore, when I say P is equal to address of A2, it will store nothing but 2009. That means in this case, this will be nothing but 2009. It will be stored at 2009. Correct? Okay. Now, this is called the induction operator. A pointer variable contains a memory address. To refer to the contents of a variable that the pointer points to, use an induction operator. That means if I am going to use an induction operator, which I already explained to you, like this, it prints the value. Therefore, this is very that already I have discussed with you. Now, let us take an example of a program sample. If let us take an example, I write integer a is equal to 3, integer b, integer star p, and therefore these are all the pointers. These are the pointers. These are the pointers which I am going. Now, if I am putting some variable like this, and I am going to just check the program, whenever you are going to, I write if p is equal to q, it prints once, and you can check the program. In the if you are not very familiar with that, what you have to do is that you make a memory map for each and every variable, and try to see how these variables are put inside those memory maps. And therefore, now how many variables are there? There are A, B, P, Q, R. 5 variables are there. You should be able to draw a memory map like this. You should draw a memory map like this, so that you are very familiar with that. You make it for A, you make it for B, for P, for Q, and R. And assign some addresses. Of course, this is 3. Now you assign some addresses to this, and while putting this the address over here, assume some address what is given by the thing and put this address over here. Similarly, whenever you are putting a star q, you put is equal to p, you put the value of p over here. That means since it is equal to p, this is going to put this value over here. R contains the address of B, therefore you put some address over here, and this address will come over here, and so on. Then you are going to write all this program, you will end up in getting the desired results. Now, this is one of the very important slide which I talked about in the starting of the class. Reference parameter to make changes to a variable that exists after a function end. We pass the address of the variable to the function. That means whenever we are going to pass a variable to a function, even if the function ends, those values reflect in the calling program. Now here, what happens if you pass it as a value, those changes will not reflect. If you are passing by reference, those values will be reflected. Now it means that I can write a main like this. I can write a function, say f, and pass address of A and address of B, like this. And in the function f, I will receive like this integer, say star p, integer star q, and any modification I will do to p and q will have effect on A and B. That means, let us take, if I put say A is equal to say 5, B is equal to 10, and here I write star I can star P is equal to say 20, star Q is equal to 40, now try to understand the program. So this is the basics what I wanted to explain to you. Now this is the main program, and this is a function. Now here A is equal to 5, B is equal to 10. I pass the address of A and B to F, and I manipulate that P is equal to 20, Q is equal to 40. Now, if I print A over here, and I want to print B over here, what will be the output?
20 and 40.
Okay, that means what you said is 20, 40. Now, in this case, A and B are not being manipulated inside main. It is being manipulated in a function f. Now you also know that I did not return P or Q back to main. But even if the value is changed, because this is a concept of reference parameter, once you are passing the address to any function, you are passing by reference. If you have removed that ampersand from there, it is passing by values. Normally, till now, most of you might have done in the first year passing by values. In that case, if I will remove this ampersand, these values will not reflect. The meaning what I wanted to say, that if I am going to remove this one, and here, if I am going to run this program, in this case, it will just print 5 over here, and it will print 10 over here. And these values will not reflect in the calling program. Now, main is a calling program, f is a called program. Therefore, these values will not reflect because you are passing a value to this. Now, it's just like you are going to change in a photocopy and that photocopy cannot reflect over here. Now, obviously, if I'm going to write a program like this, obviously I have to remove this, I have to remove this, I have to remove this, I have to remove this. Now, this is the correct program. That means you are having 4 variables, A and B and P and Q. Now, you have to know that A will only be available here and B will be available here to main. Similarly, P and Q, you will have 2 variables, P and Q will be only available to F. And these two cannot interchange or cannot interact with one another because the scope of A and B is only to main for main, and the scope of P and Q is only to F. Any manipulation what you do in P and Q will not reflect to A or B if you are passing by value. It will not reflect. But once you are passing by reference, any changes you do into P or Q will have, actually you are manipulating A and B. If anything is being manipulated by over here, by say if it is being manipulated by this like this, any changes you are doing in P and Q is directly changing at this location. Because you are passing the address of A. Actually, what you are doing, you are passing this address, Now, this is the reference parameters that without returning a parameter from F, you are going to return n number of parameters. Therefore, even the concept what holds in all pointer variable languages that you don't require to pass explicitly the values, but it is always done implicitly. Now you have to take care. If you are passing an address from any function to another function, you have to keep in mind that that you have to check that it cannot be accidentally modified by some other program. Now, in that case, you don't have any control. If a program writes something wrong, that will have a bearing on your program. Now, for example, maybe this one writes say 20.8, and this writes say 95.6. It's a wrong one. But in that case, the main program will also not function because you have put a float value over here. Now the program will crash and you will not know where the error has come because your A is passed to F might have passed to somebody else, that function might have passed to somebody else, and you will not be knowing that which function has manipulated the values because you only know that you have passed your variables to F. Now F might have passed to say K, some other function K. K might have passed to other function say S. It could have manipulated, S might have wrongly done this, but the implication of that will be felt in all the functions which are linked together. Therefore, pointers must be very, very clearly used, otherwise you will end up in getting a very drastic results which will be difficult to track the things. And therefore, reference parameter is an excellent tool provided you use it carefully. Otherwise, the errors which will come in, very common error which comes is called a segmentation fault, will is common and will come many times in a program. Therefore, this error has to avoid this error. People who are working on Turbo C compilers will not get segmentation fault. People who are working on GCC compilers, they will only get segmentation fault because in Turbo C, there is no concept of segments. You will know in the latter part of the next semester that what is a segment. Segment is one part of the memory which is assigned to you. For example, you are having a memory of 1 GB. They might give you say 100 KB, and that is your segment. Since in Turbo C can only have a single program resident, therefore all the memory is to you. Therefore, there is no segmentation concept. Though the OS has segmentation concept, but the compiler do not support that. Now this is a thing what I talked about. Just for your practice, you can practice this program that how pointer return values. This is actually I have given this one just to explain you all. This is a practice thing, and you can practice and you can do this. But this is just a practice question for thing. Now this is
Sir, how many slides are left?
only I think to. But I'll stop. What's the time now?
It's 1:05.
Okay, then I think this is the last slide. I'll stop. Therefore, it is a pointers. Now, this is the thing which I cover in the next class. It's a pointers to pointers. That means how can you write a double pointer? A double pointer means a pointer to a pointer. Now, this type of pointers are used in a 2D arrays. In a 2D array. That means if I am going to pass a 2D array from main to some other function, in that case, you require a 2D, a double pointer, a pointer to a pointer. Therefore, this I'll cover in the next class. But this concept is extendable. If you understand the concept of double pointers, you can also do it using a triple pointers. Therefore, the concept should be very clear to you how I am using a double pointer to just visualize the things and convert to a triple pointer. Therefore, that is not that difficult. And therefore, but requires practice. What I advise you that you can do a program at your home. What you can do is that you can write a program for an array, declare an array. If I just give a small question just for practice, declare an array using pointers and manipulate it. Manipulation means you declare an array. You declare an array. What you are going to do is that you are going to declare an array, and in that array, what you have to do is that you have to change the values. For example, you have put the values say 1, 2, 3, 4, 5. Using pointers, you can increment to 2, 3, 4, 5, 6. That means what you do is that you take a pointer like you take an arrow. Just this everybody can do, and I am sure that you can do that thing. What you can do is that you can declare an array like this. You can declare an array like this. For example, I put a value 1, 2, 3, 4, 5 using pointers, and you can increment by 1. All this must be done using pointers like this. That means, therefore, I expect that all of you can do it. Therefore, you have a holiday for 2 days. Therefore, when you come on maybe on Tuesday, we'll be able to do adult pointers. Now stop at this point. Anything you need to ask, you can ask.
सर ये जो the pointer must be of a type that allows it, मतलब ये थोड़ा confusion वाला part हो रहा है.
क्या फिर से बताओ.
The pointer must be of a type that allows it to point. मतलब तो ये किस तरह के types के pointers हो सकते हैं?
Any type of pointer which is being used, it has to be pointing to the same type of pointers. That means when you are going to apply a pointers, suppose I am declaring an integer pointer. Okay, it has to be manipulated using an integer pointer only. If I am taking I can declare integer star star p. Now that means p is a double pointer. It can only manipulate a double pointer. If this is the what I
ओके
understood from
ओके
your question.
ओके
Okay.
मतलब सर जो डेटा टाइप है वो दोनों पॉइंटर्स का सेम होना चाहिए, मतलब ये कह सकते हैं.
हाँ, बिल्कुल. Actually, pointers are always integer. That you should know. But the type of the pointer matters. All pointers are integers. But that doesn't mean that you can very well compare an integer pointer with a float pointer. That otherwise, therefore you require a typecasting. Therefore you require typecasting for that.
ओके सर, ओके, थैंक यू.
Okay. Already the attendance has been recorded. Therefore you can stop. You can